Hello, Algebra 2 students. Today's April 2nd and the second day of our online instruction. Today we're going to be working mostly out of our binder, so you're going to need your notes. We're going to do a little bit of lesson 4 on page 357, 358, just a couple of exercises, so if you can get your binder out. And we're also going to do unit 11, lesson 10 on pages 384 and 385, and we're going to omit one of the questions. Tonight for homework, I'd like you to do pages 386 and 87, but please omit question 1. It has sections A through F, so don't do any of that for homework tonight. Also, if you have your paper plate, I'm also going to be referring to the paper plate every once in a while. So, to get started, on page 357, we talked about this with our paper plate yesterday. When you're on the unit circle, the x value is the cosine of this angle theta. The y value is the sine of this angle theta, no matter what this angle is. And then if you put it into the x squared plus y squared equals 1, you get this Pythagorean identity, which is really, really important. And if you want to highlight this on your paper plate, you really should, because that's one of the most important things of this chapter. Today we're going to be talking a little bit more about tangent. There are quadrantal angles around here. Quadrantal angles, if you remember, they are the 0 degrees, the 90 degrees, 180 degrees, and 270 degree angles, and you can also call this 360 degrees if you rotate this around. So if you want to know what the sine and cosine of 0 degrees is, well, since the x value of this point is the cosine of theta, you know that the cosine of 0 degrees is equal to 1, and the sine of 0 degrees is equal to 0. And the cosine of 360 degrees is equal to 1, and the sine of 360 degrees equals 0. And if you go up to 90 degrees and look at this point, when you rotate around 90 degrees on the unit circle, you can see that the cosine of 90 degrees is 0, the sine of 90 degrees is equal to 1. And let's see if you can see this on my graphing calculator here. It might be too much white to see. I think it is. But if you take your graphing calculators out and you change the mode to degrees mode, and second quit out of there, and if you want to know what the cosine of 0 degrees is, you can just hit cosine of 0 degrees. You can see that a little bit. Hit enter, and it's equal to 1. The calculator will tell you that the sine of 0 is equal to 0, and you can go around all of these angles. 180 degrees. The cosine of 180 degrees is -1, and the sine of 180 degrees is equal to 0. The cosine of 270 degrees is equal to 0, and the sine of 270 degrees is equal to -1. So you should, that was one of your materials, you should have gotten your calculator out, change the degree mode, or the mode to degrees, check out the cosine and sine of all of those angles, and you can see that they're either 0, 1, or -1. Which brings us to page 357. I want to do exercise 2 down at the bottom, and I also want you to highlight what we were just talking about, that the sine of theta is equal to the y-coordinate if you are on the unit circle, and the cosine of theta is equal to the x-coordinate if you are on the unit circle. So if you have a question like exercise 2 says, the terminal ray of an angle, they call this one alpha instead of theta, if it's drawn in standard position and it passes through this particular point, so if you had a unit circle and it passes through the point -0.6, +0.8, you're talking about this point right here, -0.6, +0.8, and then you have an angle theta here, but this angle, reference angle right here, also has the same sine and cosine values, but you just have to remember that in quadrant 2, only the sine is positive. All students take chemistry from yesterday. So this angle theta has a cosine that's equal to -0.6 and it has a sine of theta that's equal to 0.8 because it's just the x value is the cosine and the y value is the sine. So this question says which gives the value of the sine of angle A. Well, we should call it A instead of theta, I guess. So the sine of angle A, because it's in quadrant 2, it's positive, but the sine is the y value. So it would be option 2 would be the answer of that question. Moving on to the bottom of page 358, I just showed you on the paper plate the quadrantal angles. This is a unit circle. You can see the radius is equal to 1. So this point right here is 1, 0. This point up here is 0, 1. This point over here is -1, 0. This point down here is 0, -1. And you have 0 degrees and 90 degrees and 180 degrees and 270 degrees. If you want to know what the cosine of 180 degrees is, you go over to the 180. And because cosine is the x value in the unit circle, the cosine of 180 is -1. The sine of 180 is the y value of this point right over here, which is 0. The sine of 270, that's the y value here down on 270 degrees. So this value is -1. 360 degrees, well, 0 and 360 degrees have the same sine and cosine values. So the cosine of 360, that's the x value, so that's equal to 1. Now the tangent is equal to the sine divided by the cosine. So if you go over to 180 degrees, the sine of theta is equal to 0, or it should be the sine of 180 divided by the cosine of 180 degrees, and the sine of 180 is 0, the cosine of 180 is -1, and so that is equal to 0. The next one, the cosine of 270, go down to 270, pick up the x value, that's equal to 0, and the sine of 90 degrees, go up to 90 degrees, cosine is 0, sine is equal to 1. So that's it on page 358. Now we're going to jump way ahead, and we're going to go to Unit 11, Lesson 10, which is on page 385. So fast forward through this. Oops, page 384. Sorry, I got the next page on here. So we're going to go into the tangent function now. And so this is just kind of a review. The two most important trig functions are sine and cosine because they happen naturally. But also there's a third trig function called the tangent. Not quite as important, but it's also there. And if you remember SOHCAHTOA, and I'd like you to write down SOHCA, so the SOHC part of it is the sine is equal to the opposite over the hypotenuse. Write this down as many times as you can so you can remember it. C stands for cosine. Cosine is adjacent over hypotenuse, and the tangent, oops, I should say cos, and the tangent of an angle is equal to the opposite side divided by the adjacent side. That's what SOHCAHTOA stands for. So just like we just said, the tangent is opposite over adjacent, the TOA part of it. And so if you wanted to know the tangent of this angle, you go to the opposite side divided by the adjacent side, you got the tangent. So with a right triangle, there are two things that you can always use on a right triangle. You can use the Pythagorean theorem, a squared plus b squared equals c squared, and you can use SOHCAHTOA on right triangles only. Other triangles you can't use that on. So what they want to know is what is the sine, cosine, and tangent. Well, you need to know all three sides in order to get all three trig functions. So let's find this missing side. A squared, we'll call this b, plus b squared equals the hypotenuse squared. Make sure the hypotenuse is always on this side of the equal sign, the largest side. So 16 plus b squared equals 25. Subtract 16 from each side. B squared is equal to 9, so b is equal to 3. So this b value is 3. So you can get the sine is opposite over hypotenuse, 3/5. The cosine of that angle is adjacent over hypotenuse, which is 4/5, and the tangent of that angle is opposite over adjacent, which is 3/4. This is a special kind of triangle called a 3-4-5. It's one of the Pythagorean triples. 3-4-5 is very common. Also, 5, 12, 13 is also a very common Pythagorean triple. It doesn't have radicals in it. This one isn't so common. This one's got the missing side b. So if you want to do this yourself, that would be great, but I'll just do it off to the side. 1 squared plus b squared equals the hypotenuse squared. 1 plus b squared. I'm going too fast. 1 plus b squared equals 4, so b squared equals 3, so b is equal to the square root of 3. So if you want to know what the sine of this angle theta, sine is opposite over hypotenuse, which is the square root of 3 divided by 2. The cosine of this angle is adjacent over hypotenuse, which is a half, and the tangent of that angle is equal to the opposite over adjacent, which is the square root of 3 over 1, which is just the square root of 3. Now when there's a missing side, use a Pythagorean theorem. That's what we just did up here to find the third side. Sometimes it's a radical, like what we just found, but not always. So just like with sine and cosine, we can define tangent in terms on the unit circle. So we have this unit circle right here, which is the same exact unit circle that we've had on our paper plate. Remember, the x value is the cosine of this angle theta. The y value is the sine of this angle theta. So what this has is x and y is that point. How can we define the tangent of the function in terms of this point? Well, tangent of theta is equal to the opposite over the adjacent side. Well, this y is the opposite side, and this x is the adjacent side. So the opposite side is y divided by x. So if you know a point on the unit circle and you want to know what the tangent of that angle is, you can just divide y by x. And just because we know that the sine of this angle is the y value and the cosine is the x value, we can define the tangent in terms of sine and cosine. The tangent of theta is equal to, remember, y divided by x from up here. But we remember, hopefully, that y is the cosine of, another mistake, going too fast. Y is the sine of that angle theta, and x is the cosine of that angle theta. So this one is kind of important that you know that the tangent of any angle, and you can try that on your calculator if you want. If we could actually see my calculator. I wonder if I turned it down a little bit. Turn the brightness down, maybe. And if you wanted to know, like, the tangent of, pick your favorite number, the tangent of maybe 25, you can find out what that is as a decimal. And you can also say, well, I wonder if that's the same thing as the sine of 25 divided by the cosine of 25, because remember, sine of that angle divided by the cosine of that angle should be the tangent, and if you press enter, you can see that both of those values are the same. It doesn't matter what angle you choose here, the tangent is always the sine divided by the cosine. Now we'll move over to page 385 on the back, and here we go again. Definition of the tangent in terms of sine and cosine. So this is the another important part of this lesson here. And what we're going to do is we're going to skip exercise 3, move right on to the next part. Because tangent involves division, sometimes it could be undefined. Remember, undefined means there is a 0 in the denominator. We learned that a long time ago, but make sure you remember that. You can't divide by 0. So let's take the angle called 90 degrees. And if you want to take your paper plate out, 90 degrees, if you rotate 90 degrees, you're up here. And the point on the unit circle for 90 degrees is 0, 1. And we have just said that the cosine of 90 degrees is 0, the x value, and the sine of 90 degrees is equal to 1, the x value. And it doesn't matter what the angle is, you take the x and it's equal to the cosine of that angle. You take the y, it's equal to the sine of that angle. So we're going to take 90 degrees, which is the same thing as pi over 2. And so we're going to state the value. Well, let's draw our little tiny unit circle here. And we don't even have to really put the whole unit circle in. All we have to do is put the 4 points in for 0, 90, 180, 270 degrees. So this point right here is called 0, 1, which is associated with our 90 degrees. So because we know that this is the cosine of 90 degrees, followed by the sine of 90 degrees, then we can say, oh, the cosine, oh, I guess they want us to start with the sine. The sine of 90 degrees is equal to the y value, which is 1. The cosine of 90 degrees is equal to that x value, which is equal to 0. Now, why would tangent of 90 degrees be undefined? Well, because the tangent of 90 degrees is equal to the sine of 90 degrees divided by the cosine of 90 degrees. Well, the sine of 90 degrees is 1. Cosine of 90 degrees is 0, undefined. Uh-oh, you can't have a 0 in that denominator. So that is why if your calculator is in degrees mode, and if you try to do a tangent of 90 degrees, you will see that you'll have an error because you cannot divide by 0. So exercise 5 says, which of the following angles is tangent undefined? Well, what we want to know is tangent is equal to the sine divided by the cosine of the angle. And if you have an undefined tangent means the cosine of theta must be equal to 0. That's the same thing. So the cosine is the x value on the unit circle. So where on this unit circle is the x value equal to 0? Well, there are two spots. Right up here on 90 degrees, the x is 0 and the y is 1. And down here on 270 degrees, the x is 0 and the y is 1, negative 1. So the cosine being 0 in these places would make the tangent undefined. And you can also take your calculator out and try to do the tangent of 270 degrees, and you'll see, again, you'll get another error. Those are the angles. You can do tangents of 271 degrees. That would be fine. They'd give you a value there, but you can't do 270, 90, because that would be divided by 0. So which one of these would match up? Right here. Option number 2. Now we know that the sine or cosine, and the quadrant, we can find the other two missing trig values. So if we are told what the sine is, all we need to know is one trig value, and we can find the other two if we know one. There are two different methods, and I'm going to show you the two different methods. One method over here, one method over here. So the one method says, if you remember the Pythagorean trig identity, it says the sine of theta squared plus the cosine of theta squared is equal to 1, and that's what you've highlighted on your paper plate here. Then they tell you that the sine of theta is 5/13. So you can say 5/13 squared plus the cosine of theta squared is equal to 1. 5/13 squared is 25 over 169. If you subtract 25 over 169 from each side, you're going to get the cosine of theta is equal to, let's see, what is that, 144 over 169. That's the squared part. Now if you take the square root of each side, you are going to get the cosine of theta is equal to the square root of 144 is 12, and the square root of 169 is 13. So you've got the cosine of theta here, and then I'm kind of running out of room. So I'm going to say right here, the tangent is equal to the sine divided by the cosine, which is equal to 5/13 divided by, I'm running out of room, so I'm going to write it like that, divided by 12/13. And if you divide by a fraction, it's the same thing as multiplying by the reciprocal, 13/12. Well, the 13s will cancel, and you're left with 5/13. That is your tangent value. And what quadrant does it say? Oh, quadrant 2. This is really, really, really important, because in quadrant 2, only the sign is positive. So what we have to do is we have to make the cosine negative 12/13, and we have to make the tangent negative 5/13, if you can read that. Let me write it a little bit better, maybe. Tangent is negative 5 over, the 13/12. This is a mistake. 13s cancel, and you have negative 5/12 is the tangent. So cosine is negative 12/13, tangent is negative 5/12. They're both negative because it's in quadrant 2. And the other way we can do this is we can make a point in quadrant 2. We know the sine is the opposite over the hypotenuse from SOHCAHTOA. So if we wanted to draw a point or a right triangle over in quadrant 2, the sine, and this is our little theta here, the sine is the opposite side, which is 5. The hypotenuse is 13, and if you do 5 squared plus b squared equals 13 squared, you're going to get b equals 12. So you can put a 12 here. And then SOHCAHTOA says the sine, we already know, they told us that's opposite over hypotenuse. The cosine is equal to adjacent over hypotenuse, but it's negative because it's in quadrant 2. And the tangent of theta is equal to opposite over adjacent, and it's negative because it's quadrant 2, 5/12. So there's two different ways. You can draw a triangle if you'd like, or you can use the Pythagorean identity if you like. It really doesn't matter. And now exercise 7 says the cosine is equal to A. A is positive. So that means if A is positive, cosine is positive in either quadrants 1 or 4. Let's see, oh, it says we're in the 4th quadrant. So now what they want to know is what is the value of tangent? Well, if they tell us the cosine of theta, you can say cosine of theta squared plus the sine of theta squared is equal to 1, Pythagorean identity, just like this. Well, the cosine of theta is equal to A. So A squared plus sine of theta squared is equal to 1. Subtract A squared from each side, and you get sine of theta squared is equal to 1 minus A squared. Take the square root of each side. Sine of theta is equal to the square root of 1 minus A squared, but because we're in the 4th quadrant, sine is negative, so you got to put a negative out in front of that. Now they're not asking for sine, they want to know what tangent is. Well, tangent of theta is equal to sine of theta divided by the cosine of theta. Well, we just figured out the sine of theta is negative square root of 1 minus A squared. They told us that the cosine of theta is equal to A, and that would be our final answer. So which one of those matches up? It looks like it's option 4, negative square root of 1 minus A squared over A. So that is that. So that's all you should know for this next piece of homework that you need to do for tonight on pages 386, 387. Please omit question number 1. And if you have questions, contact me through Teams. Have a great day. Hope all is well.